Impact Report, anticipated 50% growth in semiconductor automotive and consumer electronics industries by Q1 2025. Overview. The semiconductor industry is on an upward trajectory with projections indicating a growth rate of approximately 50% across key sectors including automotive, consumer electronics and artificial intelligence (AI) technologies by Q1 2025. This expansion is largely fueled by the increasing demand for AI-specific chips and advancements in data center infrastructure paralleling significant trends in technological innovation. Key growth drivers. 1. AI chips. The demand for AI chips is expected to exceed $150 billion by 2025, driven by a wide range of industries integrating AI technologies, particularly in healthcare, automotive, and consumer electronics. 2. Automotive semiconductors. The surge of electric vehicles (EVs) and advanced driver assistance systems (ADAS) is spearheading growth in the automotive semiconductor sector, making it one of the fastest growing segments. 3. Consumer electronics. The rollout of 5G technology and the proliferation of smart devices are projected to sustain growth in consumer electronics, albeit at a slower rate than automotive and AI sectors. Market dynamics and challenges. While the growth forecast is optimistic, the semiconductor industry faces challenges including supply chain disruptions. Geopolitical tensions, particularly between the US and China, pose risks to supply chains. US export controls on advanced semiconductor technology to China limit access to critical components, potentially leading to shortages. Labor shortages. The industry anticipates a need for over 1 million skilled workers by 2030, with a significant talent gap hindering production capacity and growth. Economic conditions. Potential global economic downturns may dampen demand for consumer electronics and lead to inventory gluts affecting pricing and profitability. Common themes across sources. All sources report a consensus on strong growth prospects for the semiconductor industry, especially in the AI and automotive sectors. Geopolitical tensions and labor shortages are consistently highlighted as critical challenges that could impede progress. Timeline of key events. 2023, the semiconductor industry experiences a downturn due to overproduction and diminished consumer demand. Early 2024, signs of recovery emerge as AI demand surges, with companies like Nvidia reporting substantial revenue increases. February 2024, the U.S. government begins dispersing funds from the CHIPS and Science Act to revitalize domestic semiconductor manufacturing. March 2024, significant rebounds in memory prices, particularly for DRAM and NAND flash, are projected due to AI-driven demand. Q1 2025, the semiconductor sector is expected to reach new revenue highs, with AI potentially propelling the market towards a $1 trillion valuation within the decade. Industry perspectives. The semiconductor landscape is evolving, with various stakeholders making strategic decisions to capitalize on growth opportunities. 1. AI and memory technology. The explosion of AI applications has driven a robust demand for high-bandwidth memory (HBM) and solid-state drives (SSDs). Memory manufacturers are increasing production capacity, with projections indicating that HBM will account for a growing share of the total DRAM market value, reaching over 30% by 2025. 2. Automotive sector growth. The automotive industry's shift towards electrification is creating significant demand for semiconductors. As electric and autonomous vehicles become mainstream, automotive semiconductor manufacturers are poised for rapid growth, further supported by government initiatives aimed at promoting sustainable transportation. 3. Consumer electronics recovery. The consumer electronics segment is expected to rebound, driven by new product launches and the continued rollout of 5G technology. Analysts forecast a resurgence in demand for smartphones and other smart devices, with AI integration playing a pivotal role. 4. Geopolitical and economic impacts. The ongoing geopolitical tensions and economic uncertainties present risks to the semiconductor supply chain. Export restrictions, particularly related to advanced technologies, may hinder growth and complicate international trade dynamics. 5. Talent development initiatives. To address the looming labor shortage, semiconductor companies and educational institutions are increasingly collaborating on workforce development programs. Initiatives aimed at attracting and training new talent are critical to ensuring a skilled workforce capable of meeting the industry's expanding needs. Conclusion. The semiconductor industry is on the brink of substantial growth, driven primarily by advancements in AI and the automotive sector. While challenges such as geopolitical tensions and labor shortages remain concerning, proactive measures and strategic investments are being implemented to navigate these hurdles. The outlook for Q1 2025 and beyond suggests a dynamic landscape where innovation and collaboration will be essential for success. Sources: 1. Deloitte Semiconductor Industry Outlook 2025. 2. Compo Electronics Semiconductor Revenue Forecasts Q1 2025. 3. SourceEngine Semiconductor Industry News, January 2025. This report provides a detailed overview of the anticipated growth in the semiconductor industry and highlights the dynamics shaping this critical sector. The trends and predictions outlined here reflect the ongoing shifts in technology market demands and geopolitical landscapes that will influence the industry in the coming years. The anticipated growth of approximately 50% in the semiconductor, automotive, and consumer electronics industries by Q1 2025 reflects a significant transformation in the global competitive landscape. Driven largely by the surge in artificial intelligence (AI) applications and related technologies. Here are some counterintuitive insights and developments from the provided content. 1. AI demand versus general market trends. While the overall semiconductor market faced a downturn in 2023, the demand for AI chips, specifically GPUs from companies like Nvidia, surged. This suggests that while some sectors experienced a glut of inventory, the niche market for AI-related products thrived, highlighting a disparity in demand across different segments of the semiconductor industry. 2. Labor shortages amidst growth. Despite the booming demand for semiconductors driven by AI, the industry faces a significant talent gap, requiring an additional 1 million skilled workers by 2030. This paradox indicates that while companies are ramping up production to meet demand, they are simultaneously constrained by a lack of available skilled labor, which could hinder growth. 3. Geopolitical tensions. The ongoing US-China trade war presents a complex backdrop for the semiconductor industry. While the US seeks to restrict China's access to advanced semiconductor technologies, this move may inadvertently strengthen China's domestic semiconductor capabilities. China is actively investing in its semiconductor industry with substantial funding aimed at achieving self-sufficiency, which could lead to increased competition in the future. 4. Price increases amidst overcapacity concerns. Although there are fears of overcapacity in the semiconductor market due to rapid investments and expansions, companies like Samsung and Micron are still increasing prices for their products. This suggests that while the industry is expanding, the focus on high-demand sectors like AI is allowing these companies to maintain price stability and profitability, countering the expectation that overcapacity would lead to price drops. 5. The role of environmental regulations. The CHIPS Act in the U.S. allows some semiconductor projects to bypass environmental reviews, indicating a trade-off between rapid industrial growth and environmental considerations. This decision could be seen as counterintuitive given the global push for sustainability, revealing a tension between immediate economic goals and long-term environmental impacts. 6. Resilience in supply chains. The semiconductor industry is addressing vulnerabilities in its supply chains by diversifying geographically and strategically investing in domestic production capabilities. While diversification is typically seen as a protective measure, it may also lead to inefficiencies and increased costs in the short term as companies navigate new logistics and supply chain dynamics. 7. Market recovery projections. Despite the challenges posed by excess inventory and geopolitical tensions, industry forecasts predict a strong recovery in the semiconductor market. particularly in the latter half of 2024. This optimism contrasts sharply with the current landscape where many companies are still grappling with low demand and production cuts, suggesting that recovery may not follow a linear path. 8. Emerging technologies versus established players. As companies like Rapidus in Japan aim to close the technological gap with established players like TSMC and Intel, the landscape appears to be shifting towards increased competition. However, the expectation that new entrants can quickly catch up to established giants underestimates the complexity and capital requirements associated with advanced semiconductor manufacturing. 9. Consumer electronics demand. The anticipation of increased consumer electronics demand, particularly for AI-enabled devices, suggests a potential shift in purchasing behavior. However, as consumers have been holding onto devices longer due to economic pressures, this could lead to a mismatch between supply and actual consumer purchasing power. 10. Global investment trends. The significant investments in semiconductor facilities in regions like Canada and Japan highlight a global race for technological self-sufficiency. However, the varying degrees of success and infrastructure readiness in these countries may lead to uneven advancements and competitive advantages, complicating the narrative of a uniformly strengthening global semiconductor industry. These insights illustrate a multifaceted view of the semiconductor industry's trajectory, where growth, geopolitical factors, labor shortages, and technological advancement interact in complex and sometimes counterintuitive ways. The ongoing developments underscore the dynamic nature of this critical sector as it navigates the challenges and opportunities of the coming years. In the report discussing the anticipated 50% growth in the semiconductor, automotive, and consumer electronics industries by Q1 2025, numerous significant insights can be gleaned that might not be immediately apparent to most readers. Here are key aspects that are crucial yet often overlooked, along with explanations of their significance. 1. The talent gap in the semiconductor industry. The report highlights a critical talent shortage in the semiconductor workforce, estimating a need for an additional 1 million skilled workers by 2030. This aspect is significant because the rapid advancement of technology, particularly in AI, requires a workforce that is not only skilled but also adaptable to new technologies. The talent gap could hinder the industry's growth, as the inability to fill positions may lead to production delays and an inability to meet increasing demand. This shortage could have a cascading effect on innovation, as fewer skilled workers means slower progress in research and development, impacting the overall competitiveness of the semiconductor industry. 2. Geopolitical tensions and supply chain vulnerabilities. The ongoing geopolitical tensions, particularly between the US and China, have profound implications for the semiconductor supply chain. While many focus on the immediate financial impacts of export controls, the broader significance lies in the long-term strategic positioning of countries in the global semiconductor landscape. The restrictions on advanced semiconductor technology exports to China, for instance, may not just affect current supply chains but could lead to a bifurcation of the technology landscape, where different regions develop their own ecosystems. This could stifle innovation and increase costs due to reduced competition. Moreover, companies must navigate these geopolitical landscapes carefully, as they could face operational disruptions and increased costs, impacting their pricing strategies. 3. The role of AI in driving semiconductor demand. AI is positioned as a primary driver of growth within the semiconductor sector. The report indicates that AI chips, particularly for applications in healthcare, automotive, and consumer electronics, are expected to dominate the market. However, the focus on AI-driven demand can overshadow other critical areas of semiconductor applications that are also essential for industry growth. For instance, while AI is a hot topic, the ongoing demand for traditional semiconductor applications in manufacturing, telecommunications, and consumer electronics should not be underestimated. Companies that diversify their product offerings beyond AI could mitigate risks associated with market volatility in AI demand. 4. Resilience of supply chains amid disruptions. The report emphasizes the importance of building resilient supply chains in light of recent disruptions caused by natural disasters and geopolitical tensions. Most discussions tend to focus on the immediate effects of such disruptions, such as delays or increased costs. However, the long-term significance lies in the potential for companies to rethink their supply chain strategies. This may include diversifying suppliers, investing in local manufacturing capabilities, and leveraging technology to enhance supply chain efficiency. Companies that proactively build resilience into their supply chains may not only survive disruptions but could emerge stronger and more competitive. 5. Environmental and regulatory considerations. The semiconductor industry is increasingly facing pressures related to environmental sustainability and regulatory compliance. The report touches on the potential for new regulations that could impact production costs and operational procedures. Companies must not only comply with existing regulations but also anticipate future changes as governments worldwide increase their focus on sustainability. This is particularly relevant as semiconductor manufacturing is resource-intensive, and companies that can adapt to these demands may find themselves at a competitive advantage. 6. Shifts in market dynamics. There is a notable shift in market dynamics where traditional players face increasing competition from agile startups in the semiconductor space. The report mentions that AI startups are securing substantial venture capital funding, challenging established companies. This trend signifies a potential disruption in the market where innovation and flexibility become paramount. Established companies may need to adapt their strategies to remain competitive, focusing on collaboration, mergers, and acquisitions to enhance their technological capabilities and market reach. 7. Focus on advanced packaging and manufacturing techniques. The report highlights advancements in semiconductor manufacturing techniques, particularly in packaging technologies like 3D ICs and heterogeneous architectures. While many discussions focus on chip design, the significance of these packaging advancements is often overlooked. Advanced packaging can significantly improve performance, reduce power consumption, and create smaller, more efficient chips, which are essential for high-performance applications like AI and IoT. Companies that invest in these technologies could gain a competitive edge, positioning themselves as leaders in innovation. Conclusion. The anticipated growth in the semiconductor industry is not just about increased demand for chips, it encapsulates a complex interplay of talent availability, geopolitical dynamics, technological innovation, and environmental considerations. Understanding these nuanced aspects is crucial for stakeholders looking to navigate the evolving landscape effectively. Companies that recognize and adapt to these dynamics will be better positioned to thrive in a competitive and rapidly changing market. 1. Growth drivers in semiconductor industries. The anticipated 50% growth in the semiconductor industry by Q1 2025 is predominantly driven by the surging demand for AI chips, automotive semiconductors, and consumer electronics. AI chips are projected to exceed $150 billion in revenue, fueled by integration into healthcare, automotive, and consumer devices. The automotive sector is seeing accelerated growth due to the rise of electric vehicles (EVs) and advanced driver assistance systems (ADAS). While the consumer electronics market benefits from the rollout of 5G technology and smart devices. Understanding these growth drivers is critical for stakeholders to position themselves effectively in the evolving market landscape. 2. Geopolitical challenges and supply chain dynamics. The semiconductor industry faces significant challenges stemming from geopolitical tensions, particularly between the US and China. Export controls imposed by the US on advanced semiconductor technologies limit access for Chinese firms and could lead to production capacity issues globally. Additionally, labor shortages and supply chain disruptions, exacerbated by geopolitical conflicts and natural disasters, pose substantial risks to achieving projected growth. An analysis of these geopolitical dynamics provides insight into how they could affect future supply chains and production capabilities, ultimately influencing market stability. 3. Talent shortages. The the semiconductor industry is grappling with a critical talent shortage, with estimates indicating a need for an additional 1 million skilled workers by 2030. This gap is exacerbated by an aging workforce and a lack of educational initiatives to cultivate new talent. Addressing this issue is essential for sustaining the anticipated growth in semiconductor production. Strategies for attracting and retaining talent, such as partnerships with educational institutions and the implementation of upskilling programs, are vital for ensuring the industry can meet the increasing demands of technological advancements, particularly in AI and automotive sectors. For the technological innovations and future trends, the semiconductor landscape is continuously evolving with significant advancements in chip design and manufacturing processes, particularly in the context of AI. The emergence of domain-specific chips and application-specific integrated circuits (ASICs) is notable, as these tailored solutions are increasingly required to meet the specialized needs of various industries. Moreover, the integration of AI in chip design processes, known as shift-left strategies, is enhancing efficiencies and reducing time to market for new products. Exploring these technological innovations and future trends is crucial for companies looking to remain competitive and capitalize on emerging opportunities in the semiconductor market. These points provide a framework for understanding the multifaceted nature of the semiconductor industry as it gears up for significant growth by 2025, highlighting essential areas for analysis and discussion. 1. The Dutch East India Company VOC and the spice trade 1602 to 1799. The VOC was established in the early 17th century and became one of the world's first multinational corporations, driving significant trade in spices between Europe and Asia. Its influence over trade routes and the control of spice production had profound effects on the global economy, leading to a shift in economic power from the Mediterranean to the Atlantic. The VOC's monopolistic practices and strategic alliances with local rulers showcased the interplay of commerce and geopolitics, much like contemporary semiconductor trade and technology dynamics. 2. The oil crisis of the 1970s. The oil embargo imposed by OPEC in 1973 led to a significant energy crisis that affected economies worldwide. The event highlighted the vulnerabilities in global supply chains and the geopolitical influence of oil-rich nations. It resulted in a shift towards energy independence and sparked innovations in alternative energy sources and technologies. This historical precedent mirrors current semiconductor supply chain vulnerabilities exacerbated by geopolitical tensions, emphasizing the need for diversification and innovation in energy and technology sectors. 3. The Telecommunications Act of 1996. This U.S. legislation aimed to foster competition in the telecommunications industry, leading to a significant transformation in how services were provided. It removed barriers to entry and allowed for mergers and acquisitions, leading to the rise of major telecommunications companies and the eventual rollout of broadband internet. The act altered market dynamics significantly, much like the anticipated growth in the semiconductor industry is expected to reshape competitive landscapes and technologies related to AI, automotive, and consumer electronics. The semiconductor, automotive, and consumer electronics industries are poised for an extraordinary transformation, with projected growth of around 50% by Q1 2025. This surge is largely driven by the increasing demand for artificial intelligence (AI) technologies and electric vehicles (EVs), alongside the global rollout of 5G networks. This analysis will delve into the anticipated changes in market dynamics, the competitive landscape, and the challenges that may arise in the wake of this growth. Key growth drivers. 1. AI integration. The demand for AI chips is expected to exceed $150 billion by 2025. Industries are integrating these chips into a variety of applications, from healthcare to autonomous vehicles, leading to a remarkable increase in sales for semiconductor manufacturers. 2. Automotive revolution. The automotive sector is witnessing a substantial shift toward electric vehicles and advanced driver assistance systems (ADAS). This transition is driving the need for automotive-grade semiconductors, with forecasts suggesting that this segment will experience significant growth. 3. Consumer electronics resilience. While growth in consumer electronics may be slower compared to automotive and AI sectors, the ongoing rollout of 5G technology is expected to maintain steady demand. Devices such as smartphones, wearables, and smart home technologies will continue to require advanced semiconductor components. Competitive landscape. As the semiconductor market expands, the competitive landscape is set to shift dramatically. Major players like Nvidia, AMD, and TSMC are expected to dominate, leveraging their advanced technologies in AI and high-performance computing. Nvidia, with its leading position in AI chip production, Nvidia is likely to maintain its market dominance, bolstered by strategic partnerships and ongoing innovations in its GPU offerings. AMD, competing closely with Nvidia, AMD is expected to capture significant market share in the AI segment with more affordable solutions and a focus on diversified applications. TSMC, as the largest semiconductor foundry globally, TSMC is well positioned to benefit from increased demand for AI chips, with plans to expand its production capacities significantly. Challenges ahead. Despite the positive outlook, several challenges could impede growth in the semiconductor industry. 1. Supply chain disruptions. Geopolitical tensions, particularly between the US and China, could lead to disruptions in the supply chain. Export restrictions on semiconductor technology and materials may create bottlenecks impacting production capabilities. 2. Labor shortages. The semiconductor industry is facing a substantial talent gap, with estimates suggesting a need for an additional 1 million skilled workers by 2030. This labor shortage could stymie growth if companies cannot attract and retain the necessary talent. 3. Economic slowdowns. A potential global economic downturn could dampen demand for consumer electronics and non-essential products, affecting overall semiconductor sales. 4. Environmental regulations. Increasing environmental scrutiny may lead to stricter regulations on semiconductor manufacturing, impacting operational costs and production timelines. 5. Technology development costs. The high costs associated with research and development for next-generation semiconductor technologies could pose financial challenges, particularly for smaller firms. Strategic recommendations. To navigate this evolving landscape, semiconductor companies should consider the following strategies. Diversify supply chains. Companies should reduce reliance on single regions for semiconductor production and procurement. This can be achieved through strategic partnerships and investments in multiple geographical locations. Invest in workforce development. Companies must collaborate with educational institutions to create training programs aimed at bridging the skills gap in the semiconductor workforce. Initiatives should focus on attracting fresh talent and reskilling existing workers. Focus on innovation. Continuous investment in R&D is crucial for staying competitive. Firms should prioritize the development of specialized chips tailored for specific AI applications and other emerging technologies. Adopt sustainable practices. Companies should align with global sustainability goals by incorporating eco-friendly practices in manufacturing processes, thus mitigating potential regulatory risks. Monitor geopolitical developments. Firms must stay informed about geopolitical tensions and market changes that could impact their operations, adapting their strategies accordingly to maintain stability. Conclusion. The semiconductor industry is on the cusp of significant growth, driven by the increasing demand for AI technologies, the automotive sector's shift towards electrification, and the resilience of consumer electronics. However, to fully realize the potential of this growth, companies must strategically address supply chain challenges, labor shortages, and evolving market dynamics. By fostering innovation, diversifying operations, and investing in workforce development, the semiconductor industry can position itself for long-term success amidst a rapidly changing global landscape.